folks, we're going to do a flipped lesson today on a new way for you to be graphing lines. Up to this point, we've been graphing lines using x and y intercepts. So we want the x-intercept, we plug in 0 for y. We want the y-intercept, we plug in 0 for x. We graph the 2 points, connect them, and that's been how we get our line. We also have looked at making lists of solutions, which is just a table, an x, y chart, and then graphing all those coordinate pairs to make our line. Well, this, using slope-intercept form, is actually going to be a lot quicker to graph lines. It's pretty easy, but you need to kind of know the ins and outs of what slope-intercept form is and what each of its pieces and parts do, okay? So hopefully everyone has one of these sheets I've handed out to you in class. This is going to be a flip book. So you're going to take it, you're going to close up all of your tabs so it looks something like this. And then as I'm writing notes on the board, I'll magnet open which section you should be writing in. Okay? And we're going to start off with all of our notes being in the top part, so the underside of these tabs. You're not going to do any of the graphing yet, which we will do on this bottom half in the second half of this video. Okay? So before we get started taking our notes, it's important for you to know, okay, and this is what's written on the cover of all of our tabs, that slope-intercept form are lines that are rearranged to look like y equals mx plus b. Now, you won't normally see it with an m and a b in it, okay, but it will always have its x and y's. M will be some number, b will be some number, positive, negative, fractions, okay, whole numbers, could be anything. This m is going to represent our slope, or the steepness of our line, our rate of change, and our b value here is going to represent our y-intercept, or where our line hits our y-axis. Now, we know we can find y-intercepts, okay, if they give us an equation, we plug in 0 for x, but here, we're going to actually be looking at a y-intercept they already gave to us and just graphing it right from the equation, okay? So let's start by looking at what each of these mean. I'm going to open up my tab right here underneath the y equals. I'm taking my notes in this section, okay? So underneath this section, we're going to put general info. Okay? That would be my title right here. The big idea here is that y, this is called our dependent variable. If you think about it, we plug in values for x, we would solve everything. Y is our output, so y depends, the value of y depends on what it is that we plug into x, okay? It's dependent because it depends on the rest of our equation. In addition to that, our x variable is going to be an independent variable. This is going to be something that we choose to plug in, okay? If it's in function notation, it might be given to you already. Like if it's f of x, we plug in a certain number for x. But generally speaking, x represents your independent variable, something you don't have control over and that you choose to put into your equation, okay? Slope-intercept form, and I'm going to put int for intercept, okay? Form always starts with a y equals mx plus b, okay? You could have your y equals over here, but generally speaking, every time your y must be alone and positive. Remember standard form, we had ax plus by equals c, and a, our x value, had to always be positive. Well, here, our m and b can be positives or negatives. Those don't matter. What does matter is that our y is alone and positive, okay? So if you, at some point, we're going to be doing rearranging into slope-intercept form. This must be a positive, and it must be, positive, and it must be alone. Okay, so you really need to isolate your y variable, and that puts it into slope-intercept form. And again, the reason we want to do this is because you're going to see it's going to be really easy once we understand our parts to graph equations that are in this form. Graphing those lines are going to take you like 5 seconds. It's going to be awesome, okay? So let's close up this tab. That's just our general information. Again, we wrote it in the top half here. I'm going to now open up my MX, okay? You can see there's going to be a lot of notes here, so make sure you write small, okay? Underneath my MX, my title I'm going to put here is that my M value is like slope, okay? That's what we call it. You will also hear your M referred to as rate of change. This is how much our line is increasing every time or decreasing every time. It's how much between each point things are changing, okay? What's happening to our rise, what's happening to our run. And in fact, rise and run are going to be part of the ratio we write for slope. The first and most important thing with slope to know is that it is always attached to the x. Okay? And by attached, I mean that it's being multiplied by x. If we rearrange equations, so don't put this down. Say I have y equals 5 minus 2x. My slope is the piece attached to the x. So even though it's not the first thing I see, it's going to be this negative 2 because it's the piece attached, again, to the x. And it's being multiplied by it. Okay? So that is our slope, always being multiplied by our x. In addition to that, slope is always a ratio, and ratio is just a fancy way of writing a fraction, okay? It's comparing two things, of rise over run, okay? So it's seen as your change in y over your change in x. If you think about it, your y-axis is vertical, right? So if something is going up, it's a change in our y. If something is moving left or right, it's a change in our x because that moves us horizontally on our coordinate grid, okay? Change in y over change in x. A lot of people will say rise over run. In fact, hopefully from middle school, you're remembering right now, oh, slope, that's familiar, rise and run. Okay, yeah, all right. If not, then make sure you have it written down so that you will know it in the future. After that, we're going to look at 4 different types of slope, and it's important that you recognize each of these and write real good notes. I'm going to make 4 mini graphs. Okay, I'm not going to put a bullet. I'm going to do this. I'm going to do another little coordinate grid with an x and a y, and then one here. Okay? And this is going to explain to you the 4 different types of slope. I could have a slope of a line that looks like this, and I'm going to put little arrows on it. This is what we call a positive slope. It's positive because if we imagine a little guy walking right up this, he is going up if we read it left to right, okay? So we imagine a guy starting on our left-hand side right here. He's walking up, so it is positive, okay? The flip side of that is if we have a line that looks like this, okay? And again, you have to read it left to right, so our dude would be standing here. He's going to take a little walk, and he is going down. If he is walking down, that means the slope or the steepness of our line is going to be negative. Okay? As we go over, we're going down. Positive going up, negative going down, reading left to right. Next, we're going to have a line that looks like this. Okay? We put our little man, he's walking. Now, he's not walking up, he's not walking down, so he's just walking flat. Okay? So not a positive, not a negative, it's a slope of 0, okay? So I'm going to put m would equal 0. Our slope is 0. Now the last type of line, going up, going down, going flat is 0, is a vertical line, like this, okay? And bear with me, this is a little morbid, but I think you'll get it. Our guy standing on it, he's getting ready to walk. When he walks, he is going to tumble down and break into a bunch of little pieces, okay? This is a special type of slope, and it is called undefined. And I remember that it's undefined because I think that when he falls off when he's walking, his body's in a bunch of parts, and they're undefined. Okay? Hence a slope that is undefined. You're going to see this happen when you maybe you get your m value, and you get a number in the top, and you get a 0 in the bottom. Okay? That's going to give you an undefined slope, and it's going to look like x equals some number. Okay? There's going to be no y in the equation at all. It's going to be just x equals 3, x equals negative 2, x equals 1/3. Okay? No y means it's an undefined slope. When our m equals 0, if you think about it, if I plug in a 0 here, where my slope goes, 0 times x means this is going to just disappear. So I'm going to be left with y equals a number, and that number is going to be wherever it hits this y-axis. So here, because it hits the x-axis once, it's x equals whatever number this is. Here, because it hits the y-axis that one time and never the x, it's going to look like y equals whatever number it is there. Maybe it's 3, okay? But that's how we get our slopes. 4 types: positive going up, negative going down, 0, not up or down, just kind of flat. And then lastly, undefined, a vertical line where he, is undefined on the ground. Little morbid, but we need to be able to recognize and have some way to remember them, and this little dude is how I remember my slopes. We're going to go to the last section now, okay? I'm going to open up my B, or plus B, and this is where I'm going to write notes also. Again, lots of stuff. You want to make sure you're using this little rectangle on your paper, just like I'm using this, okay? The title of this section that I'm going to write at the very, very top, again, I'm right here now, okay? I'm going to put that B is our y-intercept. Write it all out. And we already know a lot about the y-intercept, okay? You've been working with it a little bit already. Not only is it, well, we know what a y-intercept is, so I'm not going to write the y-intercept is where it hits the y-axis. Maybe I'll do that. But the most important thing here is that when graphing a line, in slope-intercept form, you always, and I mean always, 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 you always start by graphing your y-intercept, okay? And again, y-intercept is a point on the y-axis. So I'm going to put my m back up here. If this was 2, that means my y-intercept is 2. I'm going to start by graphing a point on the y-axis at 2. If this is negative 3, a minus 3, then I'm going to go to my y-axis, go down to where the minus 3 is, put a dot there. Okay. And we're going to talk more about graphing right after we finish our notes for this. The second thing that you need to know for this is that our y-intercept, okay, our b value, can be positive or negative or a fraction, okay? It doesn't have to be anything special. It could really be any sort of rational number that's going to work out, okay? If they give it to you, that's where you graph it. It's just where it's going to hit the y-axis, okay? Another big idea that you already know, this is found where x equals 0. So remember, this is going to be one of our solutions. If I plugged in 0 for x, I get out a y value. That y value is my y-intercept. So it's going to be easy to graph, and you need to remember, it is a coordinate pair. Our x is 0, our y is whatever number we have as an outcome. And when you graph that, it makes sense. But when you see an equation, you don't think necessarily that this is a point. Okay? It is. It's the y value when our x is 0. Because if we plugged in 0 here, that would cancel, and we'd just be left with this. Y equals b. Okay, y-intercept. Now we're going to open up all of our tabs and we're going to work in the bottom half only of our flip book. Okay, so I'm going to erase this, I'm going to pull down my graph, and we're going to take some notes here. All right? Now we're going to take what we just learned, okay, our whole idea of slope-intercept form, and we're going to take it one step further. We're going to use that equation type to help us graph. Okay, this is going to be a huge time saver. It's actually pretty awesome and it's pretty quick to do. Okay, so right now we're going to start in this bottom section. I'm going to fill out this half. I'm going to title it How to Graph. Okay, so I'm going to be taking my equations in the slope-intercept form, and I'm going to learn my shortcut right now on how I'm actually going to go about graphing these. Remember, slope-intercept form means it looks like y, it's alone and positive, equals mx plus b, where m is our slope, and b is going to be our y-intercept. Remember, both of these could be positive, negative, doesn't matter, and slope actually, if it's a fraction, makes our life easier, and you're going to find out right now. So before I do my first example, I'm going to write 3 steps here that I'm going to follow every single time when I want to graph a line that is in slope-intercept form. My first step, okay, I'm always going to graph the y-intercept first. Okay? So next to this initial graph here, I'm going to write in example 1, y equals 1/2 x plus 2. Now looking at this, I need to decide what my y-intercept is. Okay? If it's slope-intercept form, every single time the number that is not attached to the x is is not our slope-intercept. This number is going to be our y-intercept. So what that means is that this, our y-int, is going to be at positive 2 because it's a plus 2. So I'm going to graph it first. It's a y-intercept, so it's going to hit my y-axis right at 2. I put a nice bold dot. Okay? After that, I'm going to go to my second step, and I'm going to graph the next point by going rise over run from the slope. Okay? So my slope here, my m value is 1/2. What that means is starting at the point that I already graphed, right here, okay, I'm going to do a pattern of rise over run, which means I'm either going to go up or down, and then I'm going to go forwards or backwards, depending on if it's positive or negative. If it's positive, I go up. If it's negative, I'll go down. If the bottom number is positive, I'm going to go forward. If the bottom number is negative, I'm going to go backward, okay? Here, both of my numbers are positive. So that means I'm going to go, in this example, up 1, so write that in, up 1, and then I'm going to go 2 forward, because that 2 is positive. So from this point, up 1, forwards 2, up 1, forwards 2, up 1, forwards 2. See how easy that was? I graphed like 4 points and I didn't even need to think about it. As long as I understand that slope is rise over run, okay? Rise over the run, the distance up and down, okay? And side to side. After I've graphed some of those, okay, I really should do the same pattern but backwards. So for example, I went up 1, forwards 2. To continue this line in the other direction, I'm going to go down 1, backwards 2. And you can see that's still following our same pattern. I want you to graph lines on your example right here in this first graph in both directions. And then once you've graphed the points with an equation, you will always connect that line. Okay, excuse me, connect the dots to make a line. So that'll be our third step. Connect the points. Because really, each of these points is a solution, right? We plug in an x, we get out a y. But every single space in between the points, I could plug in literally 1.5 and get out an answer. I could plug in 1.7 or 1.8 or 2.35. If I could plug in anything for x and get out a y, and all of those points are going to fall on this line, and that is why I can connect it. It's continuous data. I can plug in anything for x and get a y that makes sense. Okay? Graphing that line. Let's do another one. Okay, this time we won't have to write up our steps. I'll leave them right there. We're just going to decide what's our slope, what's our y-intercept, and then graph it up. Okay? We want to get quick at this. We want to get good at it because it's going to save us so much time when it comes to graphing lines. So we're going to do the graph underneath, okay, the one right here right now. And we're going to write y equals negative 2x minus 1. We look at our steps. It says graph the y-intercept first. Looking here, the number not attached to x is my b. That's my y-intercept. It's going to be at negative 1. So on my y-axis, right here, dot at negative 1. Beautiful. Okay? After that, I need to graph my next point by going rise over run for my slope. So my slope here is negative 2. This doesn't look like a ratio. It doesn't look like a fraction. But I can technically write any whole number, whether it's positive or negative, as a fraction. I take this number, and put it in the numerator. Then the denominator is always going to be 1. Okay? If it's a whole number, it can always be written as over 1. So what this means now is this is my rise and this is my run. Since my rise is negative, I'm going to go down 2, my 1 is technically still positive, so then I'm going to go forward 1. I want you to write this in your notes. I'm not writing it for me, I'm writing it for you, okay? This slope means, because it's negative, down 2, forwards 1. So watch what happens. I'm going to go from here, not from my origin, but from here, down 2, forwards 1. Down 2 boxes, forwards 1. Okay? And look, we just talked about our types of slope, right? Positive, negative, 0, and then the one where the boop falls off, undefined. Okay? Here, if we look, this is a negative slope, which makes sense because our slope was a negative number, okay? So these do fit in together nicely. After I graph these points, I'm going to do some in the opposite direction. So I went down 2, forwards 1. I'm going to go up 2, backwards 1. And then I connect my dots as my last step. Okay? So, quick recap. We have an equation in this form. Okay? Our piece not connected to the x is our y-intercept. We graph that number first on our y-axis. Then from our y-intercept, we look at our slope, and we set that up as a ratio of rise over run. So either we're going up or down, and then either we are going forward or backward, left or right, okay? And you need to make sure, maybe you write it like this until you get really good at understanding what each of them is. But this is a very quick way to graph our line, okay? We don't have to worry about decimals, we don't have to worry about anything except for plotting our y-intercept correctly and interpreting our slope right. We're going to finish up these notes at a later point, okay? Going from a graph and then writing the equation. We're not going to worry about that now. Instead, I want you guys to focus on having equations and graphing them really, really well. So make sure these notes are somewhere nice and safe. You can see they have hole punches in it. So please, if you have a binder, you should have it like this and hole punch it safely in place so that when we come back together next class, I can say pull out your flip books and you have them somewhere nice and safe in your binder, okay? This is a great resource as we move forward, and we are going to have to finish up this section eventually, okay? But let's get good at half of the work, and then we'll add something new on top. Again, this is your homework. Hopefully you took some good notes. If not, rewatch the video and pause it when you need to, okay? I want you to come in being like, oh yeah, slope-intercept form. I wish you had taught me that weeks ago because it's so easy, okay? That's what I'm hoping for. So, thank you for watching. Hopefully everyone did their homework, and we're good to go. Have a good one. Bye.